Hi, welcome back to the pre-calculus lecture series. And in this video, we're going to talk about section 4.4. We're going to cover laws of logarithm. And this is also a very important section here. And because a lot of the logarithm operations are based on those laws here. Okay, so now let's go to our lecture notes and see what we have here. Okay, so the first things here we're going to talk about is the laws of the logarithm. So we really have three laws here, right? So the first laws here, okay, so is like if you have a log with base A, okay, and then you have like A and B. So this one, you can break it to the log A to the A plus log A to the B, see here. So in here, we need to be very careful here. That means your base has to be the same, see here, all right? So that means, you know, if you have the same base, when you combine them, you add them, is equal to one log functions and become what? You multiply them, okay? So a few things to be careful here. So the first things here, if I have log A to the A plus log B to the B, so you cannot combine, okay? So for this one, cannot combine. Right? Why? Because what? Because I have a what? I have a different base. One is A, one is B here. I cannot combine here. You cannot say become log A times B and with the base AB. So cannot combine. And other ones here, if you have this is log A, inside here is A plus B here. Okay. This is not equal to log A plus log B here. Okay, so be very careful here. They are different. You know, like if you add inside the log, you cannot break it. So the only thing you can combine is when you add two log functions, right? So then you can do a multiplication. So this is law number one. And the law number two here is this law here is A. How about if you have a divide, right? So if A divided by B, then this one's here, you can say here is A minus log A, the B is here. So the same things here. What I have here, you have to have the same logs before you can do anything, right? So also the minuses will be divided. Okay, so the number three is here. The law number three is also very important. So if this is log A and the B, well, I guess we can use A or B. That's A here, right? Okay, so then the A to the exponents here. Okay, so the third law will tell you you can bring this exponents what out, right? So you can say this is C times log A to the A, right? So these exponents here on the exponents inside the log, you can take it out as the multiplications here. So for examples here, right? So one of the very common things here we see here is like if I say I have a negative log A to the B here. So if you have a negative log A to the B, so you know this is negative ones, right? So you can really just move this negative one to the powers here. So it's a B to the negative one. So what is the B to the negative ones here? It's 1 over B, right? So if you have a negative sign, the negative log will give you 1 over B here. So I cannot those are just so important, right? Those laws, 3 laws are just so important. I cannot, like emphasize more. It's very, very important. When you try to do the log, it will help you to combine this here. Okay, so now, they say, okay, use the log, laws of the log rules to expand it. Okay, so A is pretty easy. So you said this is log, right, to the 6x here. So inside here is 6 times what? Times x, right? So if it's multiplication, what you can do here, you divide it into what? You divide it into a 6 plus log to the x's here, okay? So that is the multiplication rule. Okay, so let's take a look at the part B here. So inside here, you also have this one and this one, right? So it's the multiplication of the 2. So I say, okay, use the log multiplication rule. I can separate that, it will be x cubed plus, right? Multiplication become plus, and the base of the 5, x6. And then I can use what? I can use law 3, right? The exponents law, because both these are the exponents. So if they have exponents, what I can do, I can move to the front. So I can have 3 log 5. So you move this 3 to the front. So right now be the x's here. You see here, right? So this, you move this 3 by using the log 3's here. Then plus what happened here? This is the exponents. So what I can move to the logs by to the x's here. All right. So this one's here is corresponding to this exponents, right? So you can move to the front. Okay, so now let's take a look at the part C. This is the natural law. Remember, don't get scared by the Ln. Ln is just have a special base. The base is here, right? Okay, so for here, the first things I can see, because here, inside here, take a look at what I have. I have this number and what? Divided by these numbers, right? So I know by law 2, if they divided, what I can do, I minus, right? So you still put a natural log here. This is the AB minus the natural log, right? Square root of cube root of the c's here. Okay, so now let's continue. Oh, in here, inside here, oh, I have another multiplication. It's the A and the what? And A and the B's here. I have another multiplication. Okay, so I know I can simplify that. It will be multiplication will just be what? Plus, right? So it's log A plus log B. And then in here, okay, so I can say this is log. So this is a cube roots, right? So what is a cube roots mean? Is c to the what? 1/3, right? So I say, oh, I have a what? I have roots here, right? So I have roots here. So then which law I can use? I can use law number 3. I can move this to the front. Okay, so now let's find the final answer. This is natural log A plus natural log B. Then move this to the front as a constant, right? So it's 1/3 natural log C. That's how do we expand it, okay? All right, now let's take a look. Example 2 is a kind of go backward. I want to combine into a single log. Okay, so before we do that, let's make sure we know what is this law mean, right? So like a log A plus log B, we say it's log AB. There is nothing in front of this log. If you have 3 or you have 4, then you cannot combine. So here, there's nothing in front, right? So just like here, the log and the log, if you want to use the rule, there's nothing in front. If there's something in front, first you need to use log 3 to bring these things back. So there's nothing in front before you do it. Okay, so let's take a look for the part A here, right? Okay, so for the part A, like I said, I know how to do, add, right? So this one's here, I know how to do add if, I just can do the multiplication. But the things here is this number in front of the log and this number in front of log. Like we said, if you want to use the log 1, the multiplication, what can you do? You cannot have those numbers. So I need to use the log number 3 to bring this number inside the log, right? So here I will have log x. So this one I need to bring inside. So what is here? X to the cube. Now in here, I need to bring this 1/2 inside. So what I need to bring this inside here? I need to bring here. So this is 1/2, right? So now in here, you see here, the log, both log, there's nothing in front. So then I can just do the multiplication. So what is the final answer? Will be x cubed, x plus 1 to the what? 1/2 here. Oh, by the way, here there's no base. So everybody still remember what type of the log this one is? This is a common log, that's right. Okay, so we say the common log, typical, we don't put the base there. So that's the answer. All right, so let's do the part B here. The same idea, right? So this is 3 natural log S plus 1/2 natural log T minus 4 natural log T squared plus 1 here. So you say, okay, all right, those are my trouble terms here, right? So I have those trouble terms in front of my log function. Then I cannot use, I cannot use the loss here. So the first thing is what I need to do here, I need to bring this back, right? So I need to clear out my log before I can use the log rule. Okay, so now this one is a natural log. So S you bring back. So what is here? You bring back to the 3. And now this one's here, you bring back T. So what do you bring back here? You bring back to the 1/2, right? You put it in the exponent. Let's use the log number 3, right? Then minus here is the natural log T squared plus 1. You bring what? Bring 4 back here. Okay, now after we bring everything back, now see here, the front of the log function is clear. Then I can use my properties here. So what is the first two going to show you? This is log plus log. So what is here is log. So it's S3 times T the 1/2. Then minus the natural log T squared plus 1 to the 4. Okay, so by log 2, you minus 2. So what is here is natural log. This is S cubed T 1/2. Then this is T squared plus 1 to the 4th. Here. You get that? Okay. So the key things here for combining, what are the key concepts? Make sure there is no constant in the front. They have to be totally clear, right? Like in here, they have to be totally cleared here, totally cleared here, totally cleared here, before I can use the law of the logarithms here. Okay, so now, also here, this is another very important concept. You know, if you only have those like $5 or $10 calculator, and when you look at your calculator, I told you, right? So you only have like two kind of the keys here. One is log, one is ln. So one is a common log, one is a natural log. So if you want to find the value of the common log, so if you say, hey, log 20, you just use this keys, right? You want to say natural log 20, you just use this key. Then how about if you ask me, so I say, hey, how about if I want to find the log? Now I have a special base. I have a base 520. How I'm going to be able to do it by using my calculator. My calculator only gives me the log and the natural log key. I don't have the things I can input for any basis here. So here, this is we call it the change base formulas here. This is a very powerful, so this is a very powerful formulas here. So what is the change base formulas here? So for example, you have a log, you have a special base here is b to the x here. So these ones here, you can change to the any base. So you can change it to the log with any base x, and any base a, and a to the b's here, okay? So that's why you can change a new base, we call it the a. Then inside the log functions, you can use x and b. So now, like for examples here, right? I said, hey, I want to find the log phi 20 and log phi 20. And if your calculator only have a log, common log, and a natural log keys, so you say, how do I find it? Well, easy, right? So you can say, you use a natural log, you will just say natural log 20 divided by natural log phi, right? Because natural log is base e, you can use any base, right? You can change it to any basis here you want. And so if you say, I want to use a log, yes. So this also will be equal to the log 20 and the log phi. Right, so it doesn't matter you use an ln or log, log, it will give you the same thing. And also because of this change base and make the calculation is very convenient. You don't need to have those fancy calculator and say that, oh, I need to have a fancy calculator that can build in the log function. No, you only need to have the simple keys like a common log and the natural log. And then any other log, you'll be able to do what? You can use the change base formula, right? So that's why it's 20, you put a 20, and the phi is here, you put a phi. So you can choose any log base. So like we know this is the base of what? This is the base is, right? And what is this base here? This is the base 10s, right? So be careful, right? So that's what is this change base formulas here, okay? So now let's take a look. How do I find the value? Log phi base 8 here. So like we said, feel free to use the ln or the log n's, right? Logs here. So this one's here. Well, which one we want to use? Let's use a common log. We try the next one, use ln. It's the same. So you put the log 5 here, and then here, this is log 8. Right, so it's pretty easy, right? So 5 is in here, and 8 is in here. Then I better be careful. This is not a base, so this is 8 here. All right. Okay, so now you use your calculator and put the log 8, log 5, and log 8. So what are you going to get? You're going to get a 0.77398. So if you want to put to the ln phi and ln 8, you will get the same thing. That's what is the beauty of that. Okay, so now let's take a look at this ones here, the log 920. So what you can do here, you can say, hey, I want to do a ln 20 and ln 9. Or you can do a log 20 log and log 9. So they will give you the same ratios. So this one here is 1.36342, okay? So this is how to use your calculator. Even your calculator does not have some built-in function, then you can just use the common one, log and the natural log. I know like some like a TI-84, some fancy calculator, they do have the key, like they have here. So they have 2 places you can input, but you don't really need, right? So that your $5 calculator will work out just good because you have this very nice, the change the base formulas, right? Okay, so that's why this is the very, very cool formulas here. This is the change the base formulas here. That's it. So in this section, it's a very brief section, but it's such an important section, So we talk about the 3 very important laws of logarithm, and we talk about one very, very handy and helpful formula. It's a change base formula here. Okay, that's it. And the last sections in the log function we're going to talk about in the next video is how to solve the equation. Okay, that is also super important also. All right, that's it. And I hope that you enjoyed working with the log and you have a good day. I talk to you and looking forward to talk to you soon. Okay, bye.